Hello everyone, just another random chat. Let's see what happens in the day instead of at night here. So I'm just randomly going live like I do sometimes and just getting ready here for my next experiment. The new space for the lab is pretty well, as you can see, doing pretty good. And as far as weather here in northern Ontario, it's getting pretty cold, so I'm not used to that yet. Going outside, having to wear a jacket and all that, and even the wind is a little iffy. It's going down to like 30 Fahrenheit there at night, so it gets a little bit. I had like basically snow a little bit. They didn't stay, but it was like that ice rain mixed with the wind there. So lovely. I guess we're gonna have 6 months of that. And here we are, and I've been pretty busy actually with the Maxwell stuff I've been trying to solve. I've been explaining this in earlier videos, trying to find the unknown equations. It's been about a half a year project, and I was successful with the help of some Python programming that I was able to use to help me find compatible relationships with the help of all my research, and I was able to come up with I've published it, the new Maxwell equations and solutions, and it's a pretty thick book once it's all done. And yeah, it's available for download. It's in my videos. There's a link for it. And basically, yeah, there's a lot of research in here. I wanted to know what basically we're all in the right directions, but it's difficult when you're essentially shooting in the dark, right? So I wanted to have a clearer framework exactly on what interactions specifically to look for and what to do with. Give us hints at least, of what kind of interactions more specifically instead of, we know the generics, reactive power, resonance, and that sort of thing, but especially when you start playing with the new interactions, with the external energy sources that the traditional equations didn't really account for. So it's one thing to know that we can tap into the 0 point energy, but how and where and when and what interactions are specifically needed. So this opened up a lot of ideas for me to try, giving me a fine tune in the direction I need to go. And I was hinting on my last live session that I want to start experimenting with microwaves. Um, I didn't give out too many details. Why? Because as you see, there's a lot in here. Those who are interested, it'd probably take a month to go through it all. But I'm going to try and, go through it here real quickly and explain why it is that I'm trying to do. And at the same time, we've got to be honest, right? So a lot of people in the first page, I guess they see the first page and then they don't want to see the rest of the report because I go right down to the point, folks. There's no fluff if there isn't any fluff to add to it. You know what I'm saying? So yes, the findings are great, but it's not exactly, in some ways what I was expecting, but we can still work with that. Basically what I get into the first pages here, if I can get to it here. So basically I start with section 1, which is the extended Maxwell equations. We basically use the already known equations, and I essentially solve them in their basically symmetrical form, right, which is the traditional framework. And what I get down to is that if I can just find it here, there's a lot in here. So what I'm going to have to do eventually is, this is a lot of work, but I got to make a better table of contents for all of this. Converting tensor equations to quaternions. So I'm just trying to find the spot here. This is very important. So I'm getting into all the analysis here and the insights. Okay, here it is, the novel interactions here. So basically all these pages I was going through is all the math that supports in a symmetrical form, which is the traditional electrodynamics, and we get into the magnetic monopoles. And in the symmetrical form, what the math says is they don't exist. Okay, so the traditional science where they claim that magnetic monopoles can exist, they are correct in the form of when the system is a symmetrical system. Okay, so that's why I get right down to that point and I say, according to these calculations and all these formulas and the solutions I have here, we can indeed conclude that in its pure, symmetrical form, we cannot observe magnetic monopoles. But then I go on to exploring and finding the new unknown equations, which essentially a heart of it is when you introduce broken symmetry. So when you introduce the broken symmetry, the rules sort of change a little bit, and this is where, if you break the symmetry, and I have all the math here that supports it and tells us the guidelines on how to do it, then you could observe, which we already knew because this is dipping into like the Howard Johnson type of thing with the magnets when he shapes them certain ways, or there's these new things now called magnetic resistors, which are spinning wheels with little holes, and when it spins, it creates a certain, opening, and that's, yes, it's mechanical, but I'm just saying there are mechanisms and systems that work with that already, and through those interactions, yes, we can observe the equivalent of what would be magnetic monopoles, and I provide all of the hardcore calculations for those that want to get into that. So basically, I move on into breaking the symmetry. And what we were already talking about, when we try and use zero current to pulse coils, that's all in the right direction. But there's always the but, right? The 0 point interactions are very, very brief. They're only for a moment in time. So it's more to just take two signals and put them 180 degrees out of phase. Yes, that is part one. But the actual 0 point interactions, and I've got all the math here, and I've drew this in the previous videos. When you draw the waveform, there's a moment there where in the sine wave, let's say, where it shows, 0, but it's not really 0. It's when it reaches that area in the waveform. So what happens is, if we were to make an average of the energy gains, you'd get 0, okay? So again, someone would see that and go, why is he continuing with this? But we're breaking the symmetry, remember? So when we break the symmetry, interesting things happen. Now, yes, these 0 point interactions are very brief, but they are very well there under the proper conditions. Now, what's going to happen is during that short time, it could be a very, very high, very extremely powerful burst of energy, but very sharp. So if you average it out during the cycle, that's why you end up with 0, but with very, very, if you can collect those peaks and use the pure potential in the ways we want to, that's where you can take advantage of the system now. So basically, that led me to conclude frequency really matters. And because the 0-point interactions are very, very brief, we need to jack up the frequencies for our experiments. Essentially, we're basically doing everything right, but we're in the wrong frequency range. So that's why I wanted to start experimenting with the microwaves. Because of the microwave oven, it falls right in the ISM band in the middle of the 2.4 gigahertz band. Microwaves are much more denser in energy, and you can waveguide this energy much easier. So as I was saying in the early videos, and my last video, the microwave here I want to start experimenting with, you already have a resonant cavity in here. So it's a matter of adapting Tesla's resonant concepts with cavity resonators that will shoot out their own energy in here and potentially create an amplification loop. Now I want to drive the magnetron with pure potential instead, so I'm going to experiment with different ways of driving the magnetron and seeing if I can get some kind of microwave energy out of it. And if I'm successful, perhaps somehow we could use the ambient part anyways to drive the magnetron, use it as a trigger to kickstart this resonant feedback loop within the cavity. So that's why I set up my spectrum analyzer on the computer here, the HackRF SDR, because it has a frequency range of about 6 gigahertz. So, and what's nice about the microwave is it's all 2.4. So old Wi-Fi stuff, the 2.4, all of those antennas can be used as probes. All of the waveguide, all the mathematical formulas for, there's a rich community in building Wi-Fi equipment. So you've got all the programs all ready to build, the little tube waveguide antennas and everything. And again, much more easy to contain the RF. So it's not as prone to skin effect where even a few milliwatts gets all over the place in your circuit where you don't want it, and you get into all this high frequency madness, and then it starts interfering with all nearby communications. Essentially why I was really strongly opposed to doing any of this wave interaction mixing very seriously, because all traditional bands, in the non-microwave, even the shortwave bands, even up to 20 megahertz or so, you're going to cause more problems than good. But by moving on to the microwave bands, it really opens, and again, it's kind of like a new interaction, because you kind of get the best of both worlds with the microwave. It's almost X-ray, but it's not. It's RF, but it doesn't necessarily behave like RF. You could essentially take a piece of paper and then it'll shield half of that microwave. So very interesting properties as well. So that in part, the idea came to me by getting into all of these Maxwell equations. And it gets a lot into the curvature of space-time, so through the torsion fields, the rotating magnets, gravity waves, that's all part of it as well. So those of you who are trying to do the experiments with the Graviflyer, it's all in here. The whole framework for how to build it, what to do, what kind of interactions you need, the symmetrical interactions, the temporal effects, the quantum level interactions, the modifications of quantum tunneling, the unified field theory. It's all explained in here. So maybe one day when I want to get into this stuff, at least I'm going to have the framework now. I'll know, what to do. But there's a lot of that. So unfortunately, a lot of this is not directly related to what I'm researching, but it's very, very good information for those who are even into teleportation and that sort of thing. So it gets pretty advanced, and it gives you all the interactions and the whole framework on how to actually build it, mathematically speaking, with the new Maxwell equations. So those scalar potentials mean a lot too. don't be fooled by what traditional science wants to tell you with that. Um, a lot of conclusions in here, by the way. Like I said, it would take like a month to go through it all, but I'm just trying to get to the points that are more relevant to my research. So another section here is part 3, generating non-conservative fields with the time-varying magnetic fields. That's messing around with the magnetic flux, sort of like what Tom Bearden was doing, what he wanted to do with the mag, um, what Bedini was doing with the Chromley converter. So section 3 right here is all the framework for those who are interested in the mathematical framework, specifically to design those types of systems. I'd love to get into it, but again, not very, that's like more mechanical, workshop kind of thing. Maybe one day, but again, so how we can induce the EMF in a rotating loop, all the calculations, all the interactions, they're all right here, and it tells you exactly what to do. You can't go wrong if that's what you want to do. Just follow the framework. It's all step by step with all the mathematical. So section 2 here is the work done by non-conservative electric fields in the system and all the mathematical framework, and then how to couple the scalar waves with the regular fields and all of the mathematical framework behind that. There's a lot here. There's so much. Oh yes, a new finding that I didn't know. Under the right circumstances, a closed loop could also act as an open loop. I know that sounds weird, and that's news to me, but it tells you all right there what you need to do. And again, it's breaking the linearity, introducing highly nonlinear components, maybe even novel semiconductors that we don't have yet, stuff like the PEG cell that I've made. So that's the creative edge. At least, this gives me a framework to match the experiments that I was doing without having, it's a good guess, but without actually saying, yeah, this is what it's doing, and I can check it out. I have it right here. It's section 10 of, my Maxwell equations, and it's all simplified in here. So yeah, that was very interesting. Closed loops can act as open loops under the right conditions. So can you imagine that? A closed loop system that once it's triggered in the right, so you need a source to get it going, but once it's triggered, it could take most of its energy from an outside source, even as a closed loop. Because what happens is there's such a thing as, once you get in here, there's different categories. There's the local energy and there's the global energy. And a lot of these systems, they focus on the local and they don't take account the global. In other words, the global could be a universal energy source that complements, such as scalar, the local energy supply. And you need to accommodate for both of these. So when people say, oh, you've got over unity, it's not right, your calculations are wrong, no. It's because they're using a reduced traditional set, which doesn't account for the global source that is totally legit that you're siphoning off. Energy doesn't get created out of nothing. It's there. It's just, the current traditional framework lacks the extended systems. But we, folks, as experimenters, must understand that it is there. And in these frameworks, in this book here, it makes the solid difference when we're dealing with a local energy source versus a global energy source. So that's where there's a lot of confusion in all of this research, is when people are showing experiments and showing you results, they're not describing whether or not they are dependent on a strict local energy source like the power of a battery, or coupling that with a global energy source as well through resonance or earth fields or whatever. But the point is, there is a global energy sink to tap into as well, depending on how we do it. And it's just scientific. We need to accommodate it and put it into the framework. And in part, that's what I did with some of the new modifications to the Maxwell equations. I plugged that in there so that it can accommodate for global energy sources as well. And all of a sudden, folks, it all starts making sense, you know? So, yeah, one long story short, that's essentially what I've been up to. And like I said, pretty thick book. And a lot of it not even relevant to what I'm doing, but for other people with the Graviflyer is gold in there, man. Pure gold. So I'm just going to head over here and say hello to the crowd here. I realized been a messages. Someone's asking in PDF. Yeah, this isn't PDF. It's called New Maxwell Equations and Solutions. It's just a few videos down. In the video description is a PDF file. You can download the whole book. But like I said, it's a little rough. It's basically my own research put together as much as I could. Obviously, I fed ChatGPT with the Tom Bearden model, my research, as I found the Python programs with the interactions, What I'm getting at is it has such a good way of framing everything in the proper words that everyone can understand. So basically, that's what I did, is I used it to take my research and explain in better English what it all means. But needless to say, it's 6 months or more of intense, hardcore, research that I put together. But with that said, pretty good. I mean, it's categorized and everything, but it's so big that, I should spend the time and make like a better table of contents for it, because it tends to, there's so much in there, there's like subsection to subsection. So you get into a subsection that has a table of contents, but then, so it's okay there, from purely technical standpoint, the information is there, is available. But myself or somebody else that's better at making it into more of a book would need to eventually edit this to make it more of a publication rather than, research paper, because this is more of a research paper format than the actual, book. So, yeah, some project later on in life, I guess, and maybe somebody who's better than me who thinks this stuff is really good and knows how to frame it in a real kind of, book publication where it's, I did the best I could, I explain in the book what the interactions mean, but it can get pretty overwhelming naturally. So there's probably going to end up being revisions of this down the line is what I'm getting at. Simplifying it, making it easier to follow and that sort of thing. But you got to start somewhere, right? I mean, I was so excited when I found the information. I wanted to put it out there for everyone that it may be useful. Are you posting the report anywhere? I posted it on YouTube. I posted it on my forum. So, and I think a few people got their hands on it. So that's good. Oh, I posted it on Twitter. I have an X group, Alternative Energy Research. It's on there as well. But I don't have a lot of following on X, I guess if you're not into politics, people don't care on there too much. I got maybe like 400 people. So, but it's still something, So I'm just reading the comments here. Yes, just saying hello to everyone. I was just reading the comments. Sometimes people want my attention or they ask a question. I don't want to be rude. I still haven't figured out, though, how to keep the conversations. Maybe they do. Maybe I just don't see it. But when I'm done streaming, it seems like sometimes people say valuable information in the chat, and it doesn't show up as video comments. I don't know. I think you have to play the video back, and they play back in real time. But I find that a bit annoying. I like people to just see the whole thing. But anyways, that's not me. That's YouTube. So, yeah, I'm just trying to get this microwave open. I need to gut it. And I was going to do that there today. I know I've been saying it for a few days. But I got my screwdrivers here, and It's always tra-la-la, you know. Now it's trying to find, I've been dreading all day because it's just the right screwdriver. That could take sometimes an hour, right? That's the wrong one. It's trying to find these oddballs. Wrong one. I'm gonna have to get like an organizer where I can put these all in the. This is stupid in the bucket like this. You can't see your ends properly, but it's for space, you know. For now, I have it all in here, but it's not the ideal way of doing it because then you can't. What is this? They got an odd screw because they don't want people naturally getting into microwaves, right? I guess they haven't met me yet. It is an oddball. It looks like a diamond, like a square, but more like a diamond. Got all these ends here, but then I got all the ends, and then it's trying to find the right adapter that it goes on. Like I said, I got to organize myself a little bit better when it comes to the tools because I end up taking most of my time just trying to find out what fits in everything. Some of these. Boy, oh boy, it's really an odd ball, this one. Usually I don't have much trouble, and after like 2 or 3 tries, I get it. Got the little diamonds right here. It's either too big or too small. I'd really like to get this open. Ah, I got it. Okay, now which is it? This one here? Hey, we're lucky. Now it's going to be too tight. Nope, that's not the right one. It felt like the right one, but it's not. This is going to be a pain. I can feel it already. No, not that one. Not that one. So this is why, folks, a lot of times I don't like going live when I work because there's a lot of screwing around in between actually getting to the fun stuff, you know? And then people go, oh my goodness, that guy is so haywired, you know? But again, as I said, it's just working with what you got, you know? If I could, trust me, I'd have a better setup. Oh, maybe this one. Ah, now we're talking. Hope I'm not going to find a dead mouse or something in here. You never know when you pick it up from the side of the street, you know? But free is free, and there's gold parts in here. And I'm not going to buy a new one just to break it, right? Just let's see what everyone is saying here. Oh, he has? That's cool. I mean, I haven't, I guess I'd have to check my email or something because I go on his channel from time to time, but just like me, he uploads so many videos. There's like hundreds on there, you know, I can't watch them all. So if he does mention me, it's probably I just haven't heard it or anything like that. So far, so good here. Again, let's just hope I don't find any dead critter in here, and I'll be a happy camper. Maybe move this a bit here, that direction. I notice half of me is missing. Check my last. Okay, I will after this, no problem. Awesome. Okay, I think this is gonna work. I got them all. Usually there's something here. Sometimes you have to. There's a screw somewhere down here. Seems like where the control panel is here. There's just a clip or something. It might just be more stuck there. Seems like there's something holding it right where the nothing here. Nothing there. There we go. Just gotta use the force, I guess. Okay. Ah, great. Here we are. So, there's the magnetron. Now, what's cool about this is it works a lot like a vacuum tube, but it's actually a resonant chamber of its own, which when the electrons move around, it creates microwaves, resonant, at a very specific frequency. So what happens is it does the same thing in our Tesla experiments when we feed high voltage and we get radiant energy output. But instead of being X-rays and other harmful things, this is a much more controlled, confined to like one single frequency. So we can do everything Tesla was doing. He didn't have this in his time to experiment with. If he would, I'm sure he would have found new interactions. So it allows us to use the same radiant energy effects, but focus them all as a laser beam almost to one frequency, instead of being like a wideband splatter that's just all over, much reduced. So what happens is at a given frequency, your average power drops quite a bit because it's a wide band. The bandwidth, the more of a bandwidth your signal has, the less power naturally it's going to have, if it whatever based on the total distribution it's got, so if it's got 1 watt of power and it's spurring that 1 watt across 20 megahertz at any of those given frequencies, you're going to have a lot less than that wattage because it distributes it all. Now with this, it's very efficient because all of the radiant energy is being transmitted into one single radiant frequency. Much easier to handle this way, and also helps keep the feds happy, right? Because we don't interfere with their stuff. So yeah, so what I'm going to do here is typically there's a heater. It works just like a vacuum tube. You need the heater to usually because it's a warm. But what I want to do is I want to make it a cold cathode reaction because according to the Maxwell equations, and with this stuff here, there's more in vacuum tubes. When you make them nonlinear, they behave much differently than traditional semiconductors. So what I'm getting at is, again, under certain circumstances, we're able to induce a cold cathode reaction without needing the heater. So that could create some interesting, but this is getting into like the electrostatic kind of stuff, where you're driving it with pure potential, super high voltages instead of, because a microwave obviously is used on its traditional build, is quite a high current device, but the current is being used to give you the wattage to cook your food in as a form of microwave, right? But in this essence, I'm trying to use it as a trigger and resonance and make it nonlinear and see, we'll take it from there. At least this will give me a framework to experiment with. I'll be able to find out, how I could drive the magnetron. If I can, hopefully I can drive it cold. That's my goal. I want to be able to drive it cold. And with the spectrum analyzer, and thanks to all the Wi-Fi equipment, I could just take an old Wi-Fi router antenna and put it in there. And this is coaxial right here. Goes right into the spectrum analyzer. Close the door on that, and as far as the microwave, I've got almost as top-notch as it would be if I were in a lab, because this is the kind of stuff that essentially they would be using as well to take their measurements with. So being a microwave makes the accessibility of the mainstream. I don't have to build every resonant device. I don't have to build every transformer, because everything, especially because it's Wi-Fi, is already there. Just borrow an antenna, borrow an adapter, use a Wi-Fi spectrum analyzer, and instead of spending all this time having to build all my stuff, just to test, it really simplifies it. So I could see it's a pretty good design because, it's not cluttered. Nice little transformer, actually. Small capacitor, but nice little transformer. And I'm going to take all this out here. Take they got a filter here and the fuse box, typical. Runs the fan. So I'm going to gut a lot of this stuff out here. Just keep the magnetron and feed it from its input right on top here. On the bottom right here. Gotta find where the capacitor goes. Capacitor goes down here. So it's right here. So this is the high voltage side right here. And this is the heater. I'm going to disconnect the heater and just run off the high voltage side and see what kind of power levels or what kind of conditions we can initiate with very high voltages, zero current. Different frequency widths, different frequency types, different waveforms, different duty cycles. Just keep observing and see what happens, what works best, what triggers the magnetron, what materials I put inside may potentially feedback with it. Because ham radios, operators have used this for communication. They modify it because microwave is quite efficient if it's line of sight. So, yeah, I mean, there is definitely some form of a bidirectional potential as well. And we're going to work with that. So just saying hello to everyone here, reading the comments in case somebody has something to say here. And at the same time, I'm testing. I wonder how I've been live streaming at night, and I wanted to know if it's better in the daytime versus at night. And so far it says I've got 5 current viewers, and I peaked at 40. That seems to be about what I get when I go on late at night, so I don't think it really matters very much what time that I would log into. But I'm really happy I got the cover off of that. For the last 2 days, I was like, sometimes, I get discouraged because it's like, ugh, it's gonna take me an hour just to find a screwdriver for that. And I don't want to work on it. I know if that happens to anyone else, but sometimes it's just something. And I make it worse than what it is, right? Because you guys were all with me. It took what, 5 minutes, and I found the. But in my mind, there, that was gonna be like an afternoon journey just to find the. And I didn't want to get into it and make a mess, and so yeah. With that said, I guess I'm going to work on this afternoon, take my time and clean it up and start experimenting with that, documenting any interactions if, and start back up with my little YouTube videos and trying to explain it and showing the interactions. But just wanted to say hello to everyone and just trying to get used to the live interactions as well. I think it's good that people get to know me, a little bit of behind the scenes here. And with that said, I hope everyone has a good day, and I will wrap it up now. And hopefully, these comments won't all get deleted. I wish I could just. Maybe they don't, because no one ever complains that the comments disappear. Maybe I just don't know how to see them on my end. But with that said, thank you all for all your interactions, for following me, for subscribing, for telling all your friends which may be interested in this kind of research. Every little bit helps. And with that, folks, have yourselves all a great day, and thank you very much.